Yes, what's up? I just received questions here from uh, some of the students, not one, a lot of them, but some of the students who's doing engineering, who they do engineering in some of the institution. So they say, Mr. Hamish, you know what? I believe in you. You know, I've been trying to trying to check out a couple video, but I couldn't clearly understand. But since when I started watching video, I thought I clearly understand. I know you can do this one for me, please. Could you please show me this question? Yes, I can. So let's go to the business usual without wasting time. Let's take a question here. Right? I hope everybody can see clearly here. You know, this is Mntwana Wa Bantu Academy. Before we get started, remember to subscribe, like button is under there, and subscribe, and you can share as well. So just for you to do the play so that we can keep this project going. So let's start to the first question. Excuse me. I hope everybody can clearly see there. My apology. You know, sometimes my computer is shaking a little bit because I do everything but I'm on a hard computer. I don't have a camera, so I use my laptop and use a webcam. Let's go. And the first question, they say, given we have a summation of terms or functions, and then apply the convergence test and say if the test prove convergence, divergence, or does not confirm neither either. But they say we have to use the number ratio test. So the number ratio test. Mr. Hamish, what is the number ratio test? And then after that we have to do integral test. Okay, let's go to the solution. Let's recopy. So let's start with the number ratio test. The number ratio test. So this is a solution. I hope everybody can see there. Okay, solution. The number ratio test. So this is how the number ratio test say, right? You say L equal L. Some of the people they say R, some of the people they say L. So it's okay, whichever you prefer. You say limit and approach to infinity, and then you say UN plus 1 means whichever function you have here, like here, whenever there's an n with plus 1, and then over UN. That's how the number ratio test say. You see, and for convergence, the radius of convergence, for convergence mean radius of convergence. If this function given, or this term summation of term given, for it to converge, whatever you're gonna get here, this L, it has to be in between positive 1 and negative 1. Negative 1. For this summation to converge. So for convergence, it's always between negative 1. Whatever you're gonna get here, it has to be negative 1 and positive 1 for convergence. Remember, please do not mix this with the P-series test. For P-series test, just to remind you, we know for P-series test, this is not part of P-series, right? But just to remind you so that you're not confused. We know P, for convergence, P has to be greater than 1, and for divergence, this is for convergence. And for divergence, P has to be less or equal to 1. Divergence. Please don't confuse these two things. These are two different things. See, these are very two different things. So please don't confuse. This is P-series test, but this is normal convergence for the number ratio test. So I hope everybody can see that. So let's go to the question and start to solve and plug it in here. Okay, check out the page. Excuse me. Thank you for your patience. Just a second, please. Okay. So now we say, excuse me, let's go for the number ratio test. So let's plug in the number ratio test. So give an equation, which is that one right there. So we're gonna say what L equal to limit and approach to infinity, and then UN plus 1 over UN. Some of the book they use AN, whatever, by the same thing with math. AN plus 1 or AN. So what? Second sub the function, so I'll limit and approach to infinity. Okay, a UN plus 1 means we're going to take the same function, whatever there's n plus 1. So we're going to say 1 exactly, and then this is UN means you're going to take exactly the function D. So 1 plus, whenever there's an n, you see they say you have to plus 1. So let's plus 1 there. So we're going to plus, there's a n squared. So we're going to say this n we must plus 1. and then but there's a square. Why? Because they say whenever there's an n you plus 1. That's right, there's an n here with n plus 1 and then square. But we have to divide by un. So I'm going to say divide. Let me say divide. Let me write like this. So I'll say divide. Let me do like grade 1 so that's going to be easy for you. Divide by un. What is a un exactly? What is given there? So 1 plus n squared. And the next step, we know from grade 1, grade 2, we learn that whenever we have a division, we can flip. So we're going to say L equal to limit n approach to infinity. And this going to be 1 over, now we can put it in, it's going to be 1 plus square root in here, this going to be n squared plus 2n plus 1, and then we're going to multiply, we're going to flip it, so it's going to be 1 plus n squared over 1. Cool. So now we see our L equal 1 plus 1 equals 2, so it's a limit n approach to infinity. It's a D atom, but remember, right? So this is going to be 1 over n squared plus 2n, 1 plus 1 equals 2, plus, and then we multiply the 1 plus n squared over 1. So 1 times L equal to limit n approach to infinity. Everybody can see that. And the 1 times whatever, same thing. So we're gonna be left with 1 times whatever is same thing. 1 times that one, and then over n squared plus 2n plus 2. So now we go to the law of limit, right? So we have a law of limit. We divide it by the degree of highest n, the one of the numerator. So we're gonna say L equal to limit n approach to infinity. And then I'm going to divide it by the highest degree of n for each number. You see, for each number. So I'm going to say 1 over highest degree is n squared divided by n squared plus this also. I'm going to divide by n squared also. The highest degree of n. So this can be n squared also. I'm going to divide by n squared because the highest degree is n squared. So and the plus 2n over n squared and the plus 2 over n squared. This is going to give us 1. So we say L equal limit n approach to infinity. Everybody can see there, approach to infinity, and then it's going to be 1 over n squared plus 1 n squared over n squared equal to 1, and then over n squared over n squared equal to 1 plus n and 1 n goes, so 2 over n plus 2 over n squared. Okay, so now the next step, we could substitute the limit in, but I will know, okay, so this n goes to the bigger number, means infinity. So 1 over bigger number, 1 over bigger number, 1 over trillion. Okay, you have a, how am I say? I'm gonna talk the same story, man. You have a 1 mango, and you have like 1,000 friends, or 1 chocolate, but you have like 1,000 friends. So what happened? Means your 1 chocolate, everybody's gonna get very small. If you have to break down, if you have to break your chocolate to all your 1,000 friends, or you have a chocolate, and then the whole school, everybody want that chocolate. What happened? Nobody gonna get anything. That's what 1 divided by this n bigger number equal to 0. So we're gonna say what? L equal to, now we're not gonna write limit anymore because we substitute in. So this gonna be 0 plus 1 equal to 1 over. This is just 1 because this n won't affect anything. This is a constant number, and then plus. This is the same thing here. This is gonna be 0 because 2 divided by the bigger number, 0 plus 2 divided by the bigger number square, 0. Okay, so finally L equal to 1. So for the series to converge, means it has to be in between. Let me use a black pen here, right? For series to converge, it has to be between -1. Mean this L you get here, it has to be between -1 and 1. But if we look careful, we got 1 here. So if it's 1, see, it does not confirm neither. So using the Arnold ratio test, we see is not in between here. So and we see is 1, so it doesn't confirm neither. Using the Arnold ratio test, it does not confirm either. It diverge, converge. So say using the Arnold ratio test, so I can just finalize say using. So the page is finished there. The Arnold ratio test. The series does not confirm neither whether diverge or converge. So that's the answer. and thank for your patient time. So the next part here, we're gonna have to prove using integral test. So let's go and prove using integral test. Okay. So using the element ratio test, we have seen the series does not confirm neither because it fall under 1, so it's not in between -1 and 1. So the series does not confirm either. So let's use using integral test. So we're gonna do the same equation using the integral test. Okay, using the integral test. So we're gonna say using the integral test. So given from the from the question there, equal to 1 over n square. But using the element ratio test, so we have checked the element ratio does not confirm neither in our integral test. Let's go for integral test. So if somebody give you n equal to 1 given, just like given 1 plus square, this is same as writing integral n equal to 1, and then our limits from 1 to infinity, and then you have a 1 over 1 plus n square, and this is gonna be 1 over x square dx. So you're gonna write this as an integral, but don't write n here. See, make sure you change to x if you wanna test this integral test. So change this n to x, or n number, it could be y, and then here say dy. Don't say n here, you're gonna be trouble. So now we say, excuse me, thank you. Okay, so here we go. So now we're gonna have to integrate this. So before you integrate, remember this is undefinite integral. It's undefinite. Definite integral. So if it's undefinite integral, we have to make it finite integral. So how are we gonna make finite integral? So we're gonna have to limit, because we have to change this undefinite integral to finite integral. So we have to make it to finite integral. So how are we gonna change the make it finite integral? We have to change this one here. Excuse me, this one here to a certain number, because they say our limits start from 1 to a certain number, but we don't need that infinite number. So we're gonna say limit to any number. So I'm gonna say limit how am I say, let me take any number. Oh, I'm gonna say limit Soweto. Okay, limit Soweto or Soweto equal to infinity. Anything you can say n. Most of the book they say n. Okay, let me go for n. So say, hey, Mr. Hamish, some book they say n. Okay, let's go to n. So n approach infinity. So we're gonna say integral 1 to n. We're not gonna write infinity anymore. So we're gonna say n, because we wanna change this integral to finite integral. And they say 1 over 1 x squared dx. Mr. Hamish, but why you change to finite integral? The reason why we change to finite integral, excuse me, so you integrate your integral from 1 to, you don't know where you're gonna stop. You see, so most of the time, when all the time when you integrate undefinite integral, you have to change to finite integral phase. And they go, that's how to change this to finite integral. How you do that? You have to change this limit to a certain number, maybe 1,000, 2,000, 3,000. So I can say 1,000 because I don't know, it could be 2,000, 3,000, or 5 or 6, and that's why I call it n. So that's why I have to limit this equal to n. Okay, so now when you integrate this, so this is a ton. Okay, let me just keep a note here, just in case if you forgot how to integrate. If somebody give you integral of 1, let's say 1 plus y dy here, square here, square. This same say a tan or tan inverse. When you say a tan, means tan inverse, a tan of y. If there's no limit, you plus c, but for this case you have a limit. So for this case, what I'm saying, hold on just a second, please. I just fall, my pen just fall. Okay, let's go. So for this case here, we're gonna say limit and approach to infinity, and this is gonna be arctan. So this is gonna be arctan of x. Don't say square, just x. And then we have a limit 1 to n. Sometimes arctan is tan inverse. So if we say limit, it is Hamish, Mntwana Wa Bantu Academy. What is arctan? It's tan inverse. So tan inverse of x. We have a limit start from 1 to n. And then next step is substitute upper limit minus lower limit. So upper limit minus lower limit. Okay, upper limit minus lower limit. Okay, we go. What is upper limit? Is n. So we're going to substitute in. We have a limit still in approach to infinity, and then go in. So it's going to be tan inverse of n minus tan inverse of 1, or arctan of n, arctan of 1. Here we go. So now tan inverse of 1 equal to pi over 4. Equals pi over 4. Okay, so this is going to be pi. No, tan inverse of 1. Excuse me. We say, excuse me, so tan inverse of 1 equal to pi over 4. Just try to plug in calculator, and then we have a tan inverse of n minus. Okay, and then we still have our limit here. Excuse me. We still have our limit for closer. We still have a limit and approach to infinity, and then we have tan inverse of n minus pi over 4. Man, I should not rewrite this, it's just waste of time. So now, because I wrote the same thing on my phone, man, we said, Hamish, man, how did you explain to me like that? Yeah, I did. So now what happened next? We're gonna substitute this limit in here, but this limit won't affect the next number because we limit in approach to infinity. There's no n here, so this pi over 4 won't be affected. It's only gonna be affected here. So you're gonna say, no, we're not gonna write limit anymore because limit go in here. It's gonna be tan inverse of infinity minus pi over 4. But a tan inverse of infinity is pi over 2 is 90. It's like how I want to say tan of infinity. Excuse me, my point. Tan inverse of infinity equal to pi over 2. Plug in the calculator, but I don't think calculator is going to give to you. But I say tan inverse of 1 divided by 0. It's going to say error, but it's 90. Or say tan of okay, try to figure if you can figure out, let me know. But a tan inverse of infinity equal to pi over 2. If you have a problem, just let me know. See, so tan inverse of infinity equal to pi over 2 minus pi over 4. You see, because if you say tan of theta 1 over, like, let me write here so that it doesn't confuse. Tan, let's say angle equal to 1 over 0. If you invert this, 1 over 0, it's going to give you 90. Excuse me, which is pi over 4. So we're going to say, okay, so let's just say tan inverse, because 1 over infinity, 1 over 0 is undefined. 1 over 0 is undefined. So tan inverse of undefined equal to pi over 2, which is 90. So your angle here equal to 90, which equal to pi over 2 if you have to change it to radians. So now pi over 2 minus pi over 4 equal to pi over 4. So if it's pi over 4, what is a pi? Plug in the calculator, 3.14. 3.14 divided by 4. 3.4 divided by 4 is 0.70 something, 0.7. So it's in between. So this L is 0.7 something, or 0 is in between. Plug in the calculator this. Go to calculator, say pi over 4. Just pi. Shift yellow pi, you know the yellow pi I'm talking about right in the calculator. Yellow pi and then divide by 4. Okay, it's gonna be between, mean this pi over 4, which is L, is between -1 and +1. So for that reason, these series converge. You see, so we have done the same question, use integral test, and the integral test proved to us that the series converge. But for the Allen ratio test, the same question, it didn't prove neither. It didn't. We couldn't confirm neither because it gave 1, and for 1 you cannot confirm. So we say pi over 4. Finally, so say pi over 4. Shows me. I hope everybody can see there. Yeah, how it pi over 4. See between -1, +1, and -1. So this series here converge. Let me write here converge. Using integral test. I just got my message just received now. This lady, she said, hey man, you know what? That's what you did. You make me clearly understand. So if you have any question, please just let me know. Don't hesitate. Just like this program just to motivate people and believe that everything's possible. So just let me know. Leave a comment. Like I said, don't forget to subscribe and click the like button. Any question, just WhatsApp me You can watch, you can leave the comments, you can leave the question there. I can always solve your question. I'll try my best what I can. You have learned my mistake, you have learned quite enough of what I did, and any suggestion, opinion, feel free to write to me anytime, 24/7. I can always get back to you as soon as I call. Thank you very much. This is Mntwana Wa Bantu Academy. Thank you so much. Appreciate it.